how about we do a video on this? This is a 36-inch Galaxy's Edge lightsaber blade. There you go. And it is broken. I don't know how it's broken. I just know that it is broken. So let's see if I can figure out why it's broken and how to fix it. We have the whole thing. All right. Just looking at the contacts real quick. Trying to see if there's anything obvious, anything wrong. It's definitely been used. You can see the points where it's been pressed into, right, with the contacts inside a hilt. Speaking of which, here is a hilt. Throw it in and see what happens. It recognizes that there's a blade there. And it is not igniting. Not a sausage. Alright. Fair enough. So, what is it going to be? Make your guesses now. There are 3 pins, right? There are 3 contact pads. Data, power, and ground, something like that. Coming into this thing, the data pin is how the hilt knows that something has been inserted. When it sees a voltage on the data pin, it knows that a blade has been inserted. So that makes me think power is going up and data, the data line going back are good, but maybe the ground wire has broken somehow. That is going to be my guess. How did it break? I have no idea. A bad solder joint that, worked, after it was manufactured. They do a quick power test just to make sure it lights up and that everything's working fine. But then, maybe in shipping or you get it home, you'll whack the blade a few times and you knock loose a bad solder joint. That is going to be my guess. We'll find out in a moment here. Shall I zoom in so we can all see together? That black wire right there would be the suspect ground wire. Get the bottom out. Okay. And what's that? What's that little spot up there? That's not supposed to be there. The wires certainly look like they're touching. What about the... Oh, that ground wire might have a... Oh, it just looks like terrible solder joints all the way around. But they're probably good. Let's see here. Let me grab the ground wire here. I'm not seeing that joint wiggle. Not seeing that joint wiggle. That's not wiggling either. I'm going to go out on a limb and say those wires are fine. What version of the board? We've got a newer revision. You can see here it says 2021 April 7th. It's got, that's a voltage regulator marked U3, but this right here is the new component. It's a PNP transistor that I believe is being used like a buffer between the data line and the microcontroller. Could that have gone bad? That could be a suspect issue, but I am looking over here, and there is just a lot of gunk over here. Put this on continuity mode. Every time the probes connect, we get a beep. I'm actually going to flip this over. That's the ground pin. You're not seeing anything. All right, take 2. Data pin. At least up to the joint, I'm getting a connection there. And power pin. No, ground pin. Ground pin to the capacitor. That proves that the connection through the joint is good. Power pin. Power pin? Nope, there we go. Alright, so that tells me that the connector and the wires appear to be okay there. This is going to be, I'm going to measure some resistance here from the data pin, which is here, to the base of this transistor. I should get 1 kilo ohm. 1 kilo ohm, yep, alright. And, what is it? Emitter to base, if I put this on diode check. So if I go from emitter to base, I should see about 0.6 volts. And I think that goofiness there at the beginning is a capacitor being charged up when I did that. Anyways, so that makes me think this transistor is correct. We could do, what is it, emitter to collector, right? Part of the problem is I'm putting, oh, there you go. Part of the problem is I'm putting voltage into the PCB, so components are waking up and trying to do stuff with the tiny voltage this thing is putting into it. So that seems okay so far. I think I'm going to put some voltages across the LEDs and see if the LEDs light up. Alright, so you can sort of get an idea of what I'm doing here. I'm probing one of the 4 GP pins, one of the 4 segment pins that provide power to the segments, and then a cross between that and one of the color pins, specifically blue here. Yeah, and I have all the segments lighting up there, when only one segment should be lighting up. So there is a connection here. That could be the issue. Let me grab some alcohol. Okay, I have some isopropyl alcohol, and I am going to just cover this section with it and try to hopefully dissolve whatever this gunk is that I keep seeing everywhere. Or I just break out my soldering iron and reform these joints. Let me flip this over and clean up the back as well. And for that I'm going to use this to hold it up a little bit because it's still kind of crummy. Is that a loose piece of solder? That certainly looks like a loose piece of solder. Yep, that was. Yeah, these solder joints don't look great. Yeah, it's like whoever was either assembling this blade or trying to mod this blade just either had the wrong iron or the iron just wasn't hot enough. Or maybe they even used the wrong solder. I mean, that's possible. But I kind of doubt it. I'm leaning towards just carelessness. Alright, let's see if that did anything. I can see the LEDs right here lighting up. They're not supposed to be lighting up. They should only be lighting up when I hit touch over here. Makes me think there's something a little weird going on here. I'm going to do a quick reassembly. Nope, still busted. Okay, well, let's put this on resistance. And resistance between these two should not exist. Or should be infinite. Close enough. Across 3 and 4, no resistance. Across 3 and 2, no resistance. Across 2 and 1, I'll just do it across these, I guess. Clearly something there. I think our problem is with segment 2. Do you think it's that? I can just pull that transistor. I don't know why I'm just sitting here staring at it. Let's just pull the transistor and see what happens. If I keep, there we go. Let's see if I get any of those weird resistances still. Looks like I do. Alright, so what I'm going to do is I'm going to take the blade controller off completely and we'll see how that affects things. I don't know if it's the LED side or if it's the blade controller side. There we go. Okay. There. That didn't take so much effort, did it? Okay, both boards have been cleaned up of all the flux. Now it's time to do some tests again, repeat what I did before. And let's see if we can determine if it's the blade controller or the blade, the LEDs. I'm going to put this into diode mode, 15 volts. And if I ignite the first segment, blue, fine. Not see any hints of ghosting that I was before. So I think the LED strip is fine. Absolute worst case, I can just go and put one of my custom blade controllers on it. Right, back to this. Now if I put ground on pin 2 and this on pin 3, still getting something there. But as soon as I put ground on a different pin, I don't get anything. So pin 2, or the line 2 here, is definitely where there's an issue. But I don't see where that's connected to anything anymore. I suspect all those transistors that say Y2 might be bad. So I'm thinking I might just wind up pulling them all. I'm still thinking, though. Still thinking. So what I've done is I've replaced all 4 of those transistors. I don't think those transistors were bad, but I got rid of them. And before, when this was measuring resistance, and if I put the ground on that pin 2, I would see something. But now I'm not seeing that. So whatever the fault was, maybe it was one of those transistors was bad. Whatever it is, that issue seems to have cleared up. So maybe I've fixed something. I don't know. I did also notice, focus, that this pad here on this capacitor has been lifted. I probably did that. I don't think that was a problem. I almost certainly did that when I was bending this up. So what I did is I soldered the top pad, so that's going to stay in place now and not fidget around. And I may just trim that excess off as well. So the plan now is to reassemble the blade, put this back to the blade, fire it up, and let's see what happens. And I'm going to keep these transistors off to the side and maybe go find my transistor tester and put them on it and see if they come up as good or bad or whatever. Okay, time for a reassembly. The PCB in its little housing here. Everything looked good. Everybody happy? Okay. Nope, nothing. I've installed my own custom blade controller. I am impatient. I'll troubleshoot that other controller later. I want to hook up to like a logic analyzer. I want to put some wires into it and try and figure out what's going on with it. Because whatever the failure mode is, somebody else probably has already experienced it, and it'd be nice if I could identify it, you know, to help other people out. Ready? Hey, there's a blade. Let's turn that. So the blade, the LEDs work fine. There we go. One more custom blade to add to the pile. We can take a look at the transistors real quick that I pulled out of that thing. They're going to be good, I bet. This is just a little testing device. I forget how I even turn it on. There we go. So what I want to do is I have these pads over here. I could probably do a little bit of a scrub from a pencil here just to clean up any oxidation and other junk. I just kind of want to come on, like that. PNP transistor, as it should be. Anyways, I feel pretty confident that those were perfectly good transistors that I replaced. There's so many things it could be, so much to investigate. I'll put this to the side and take a look at it later. A few days have passed, and I finally came back to taking a look at this blade controller, and I've put it into this little test jig that I have set up. I have wires coming out from the ends here, down to the breadboard here, that are then being brought over to the logic analyzer. The reason I'm bringing it down to the breadboard is I want to pull some of these lines low and some of these lines high, because if I don't do that, the logic analyzer is not going to get a great signal. I also have the data, power, and ground pins also going to the breadboard. I hooked everything up. I plugged it in, and this little DigiSpark clone here has some code on it to send power on and power off signals to the blade controller to make it do stuff. And in theory, when I press this button, it sends a command over. I hooked this up and I tested it, and nothing was happening. The blade controller was not behaving. The data line was good. It was, the commands were being sent correctly, just for whatever reason it wasn't interpreting it. And so I went back, and the only thing that I found wrong was the pad for the capacitor here that had been lifted. And that was the problem. That capacitor, the through hole for that capacitor, brings power from the voltage regulator, which is hidden under this brown wire here. See that little device right there? That develops 3.3 volts from the battery pack that's in your Lightsaber hilt, and it sends it to the microcontroller, which is on the bottom of this PCB. And the path is through the capacitor here, through the through hole that the capacitor gets soldered to. And so it comes underneath, and it travels up along here into the microcontroller. Well, this pad had been lifted, and that broke the connection. The microcontroller just wasn't getting any power. So there's a test point for the voltage to the microcontroller right here, right next to it. So I soldered a little piece of wire between the lifted pad here and this test point, powered everything back up, and the microcontroller, or the blade controller, is working fine now. So I don't think that lifted pad from this capacitor, I don't think that was something that I introduced. I think that was the original fault for the blade, and that's why it wasn't igniting. In looking back at the video, when I first opened this up. You can see that the solder on this joint here isn't really good. All the solder is on the bottom half. There's no solder coming up through the hole to make a better, more sound mechanical connection. So all of the stress on this capacitor is being transmitted to the pad that's on the bottom here and nothing else. And the only thing holding that pad down to the PCB is a little bit of adhesive and the strength of the copper, the very thin copper trace running up to here. And both of those just gave way at some point. Probably the blade gets rattled around a little bit. This relatively heavy capacitor wobbles and it snaps the blind, and that's the end of that. It's an interesting failure mode. It's a new one for me. I get my hands on more and more blades that have failed and start looking into why they failed. I hope to create sort of a little list of common failure points for blades so people in the future can have an easier time troubleshooting them. Go check the common spots first, which have been either one of these three wires coming into the blade not being soldered correctly and coming out, or now it seems one of these pads lifting that provides power to the microcontroller. So at least right now it seems that the common failure modes are the solder joints all along the base here, the ones that are done by hand. I think I was thrown off when I saw those weird voltage readings or resistance readings down here. I'm not sure what exactly that was, but in any case, this is now a functioning blade controller. It was just that capacitor's pad had come off and broken the connection of power going to the microcontroller. That's all it was, and a little jumper fixed the whole thing. So there we go. At least we have an ending, an understanding to why that blade was broken in the first place, and now we know what to look out for.